Okay, so good evening. After a very long break, we have resumed our OM class. Okay, so we have covered up to third unit. Okay, we have completed third unit. Okay, so we will be starting unit number 4, which is applications of operation research. Okay, this is an important unit, unit 4. This is PP and C. Okay, this consists of 20% weightage. Okay, so this is an important unit. So kindly attend the classes for this unit. Okay, so you can score maximum in this unit. Yeah. Okay, so let us start today's class. uh, okay, so basically what is operation research? Okay, so you can note down the definition of operation research. Operation research is nothing but it is an analytical method of problem solving and decision making useful for management in the organization. Okay, so operation research is nothing but it's an analytical method, or you can also say it's a scientific method. Okay, or a mathematical method. Okay, this is a scientific or a mathematical method of solving problems, so management can take decisions based on our method. Okay, inverted array. Yeah. Okay. Okay, so where is operation research? What are its applications? So operations research is used in many areas. So he has listed out many areas in 4.1. You can take a look. So it is used in national planning and budgeting. So preparation of 5-year budgets, okay, and estimation of GNP, GDP, population, okay. So these mathematical methods, using these, they predict the GDP and how the economy will progress and how the population will progress. Okay, so operation research is used in national planning, budgeting. It is used in defense service operation. Okay, so it is used, to formulate battle strategies and uh, so the inventories and the mobilization of troops, and if you need any ammunition, so what ammunition and how much and how we can send in a very fast manner. Okay, and it is used in industries. Okay, it is used for research and development. It is used for business management, agriculture, education, public works, transport, budgeting. Okay, so there are many applications of operation research. Okay, so you can go through the list provided. Yeah. Okay, so basically any operation relation problem, how will we approach? Okay, so we are going to approach, the steps are given, so we will follow these 5-6 steps which he has provided, we will look at how to solve them in the problem also. Okay, so let's look at what are the steps involved. Yeah, so steps for solving a problem through OR. Okay, so step 1. Step 1 is formation of the problem. Okay, so what do you mean by formation of a problem? So in a problem, if you see, he will say minimize cost for doing so and so, find the minimum cost. Okay, or how can the organization profit more, so maximize profit, minimize cost. So that is called our objective statement. Okay, this is called our objective statement. So this is the problem. So we have to look at what he wants us to do using the given data, and that statement will be our problem statement. Okay, step 2 will be making a model. Okay, and also while formulating the problem, so you have to take into account all the variables. Okay, so suppose he says maximize profit. Okay, and he gives you the details of labor cost, raw material cost, overhead cost. Okay, and he says maximize profit. So these become your variables. Okay, so these are the variables. So all the variables that are related to our main problem statement. Okay, so these variables, we have to formulate the problem using these variables. Okay, yeah. So these are also called as constraints. Okay, yeah. And step 2 is making a model. Okay, so using these variables, we have to make a model so that we can arrive at the problem. Okay, step 3 will be solution of the problem. Yeah. Step 4 is validation of the model. Step 5 is feedback and control on solution. Okay, and the last step is implementation. Okay. Okay, so in OR there is something called iterations. So what happens is, so suppose you have one problem. Okay, he says maximize profit. Okay, and you have many variables. Okay, you have cost of raw material, you have labor hours. Okay, you have utilities. Okay, and then you have overheads, you have rent. So suppose you have many variables, So what happens is formulating a model with so many variables, it will be very difficult sometimes. Okay, so in that case, what you do, sometimes you make assumptions. Okay, so these assumptions, so first what you will do, you will make an assumption saying that, okay, let me assume raw material price is constant. Okay, utilities, overhead and rent is constant, and let me see how my profit is varying with only labor hours. Okay, so this is all what is called, assumptions. So if you assumptions you make, and then you try to make a model. So you make a model with only labor hours. So you get something like, so this is labor hours and this is your profit. Okay, so the more the labor hours, so suppose it's a straight line. So your profit decrease with increase in labor hours. So you get some kind of a model like that. Okay, and then what you do again, for the next iteration, you maybe probably you keep this as constant and then you vary this. Okay, and you see, okay, if your raw material is ordered between this range, my profit is in this range. Okay, so this is called iterations. Okay, so you make some assumptions and then you find out a solution, and after that, what you do, you do a feedback. So you try to combine all your models, so you get one solution. Okay, so this is kind of an approach of the OR method. Okay. Okay, now we will look at the different methodologies in the operations research. Okay, so basically in operation research, there are three types of methods. One is analytical, second one will be your trial and error, and the third is simulation. Okay, and these two methods are called as deterministic methods, and this method is called stochastic method. Okay, so firstly let me tell you what is the difference between deterministic and stochastic. Okay, deterministic, this is known as deterministic method. Stochastic. Okay, yeah, so what is a deterministic method is, deterministic as in it is a certain event. So the happening of the event is certain. Okay, so we have been discussing about EOQ, right? So EOQ is an example for analytical method. Okay, you want the spelling, I'll write it again. Stochastic. Okay, yeah, so EOQ, that is economic order quantity, right? So this is an analytical method. Now what is an analytical method is, so you are trying to make a model of your problem statement, and there is a solution which comes in the form of a certain equation. So say it may be y equal to mx plus a straight line. Okay, or it may be, a parabola, or it may be, a hyperbola, something. So you have a clear-cut relationship. You can find a clear-cut relationship between what you are trying to do and your variable. Okay, so this is called a deterministic, or this is called an analytical method. Okay, in analytical method, there is a clear-cut relationship between your problem statement. For a problem statement with the variables which you have, you can get a clear-cut solution. Okay, so that is called an analytical method. And suppose how you will get that? So you will get the solution using, so suppose if you have two levels, he says profit at, sales of 100 units, you get a profit of say 1000 rupees, and he also gives you sales of 200, will give you a profit of 1800. So if he has given you something like that, so you have 2 points, right? And he says that it's in a straight line. Your profit is in a straight line, suppose. So this is your units, and this is the profit. Okay. So if this is in a straight line and you have 2 points, you can get an equation, right? So this kind of a method where you can clearly derive at your solution is called an analytical method. And sometimes what happens is you cannot derive at an equation like this directly. So you do not have a method where you can directly derive the equation. So there you will use hit and trial method, trial and error method. So you will assume he will give you that this is the profit at so many levels, 1, 2, 3, 4, 5, and then you are supposed to make a model. So what you do, you form some kind of an equation. Say you will say y equal to you say profit equal to 10 into sales plus say 1000, something kind of an equation you will write, and you will try plugging in the values. Okay, and at some level, after you keep changing, then you do 11s, then you will do 15s, then you will do plus 600. At some level, you will be able to get some kind of a very close relation. Okay, so that kind of a method is trial and error. So you keep substituting the values, and you will find, you will get into some kind of a solution which is again a deterministic solution. So this is the trial and error method. But what is simulation? So simulation is something like you will run simulations. A computer, it will take a program and it will keep running simulations until it arrives at a model. Okay, but this involves probability. Okay, it is not a 100% accurate model. Okay, so it will give you a model and it will say probably it is 96% accurate, or it will say it is 50% accurate, that the output will follow this model. So when you are dealing with probabilities, that is called stochastic method. Okay, and when it is a certain correlation between two variables, then it is called deterministic method. And if you can clearly arrive at it, like you have EOQ, you have NPV, IRR, these are all analytical methods. But if you cannot clearly arrive and you have to do some experimentation to get there, that is trial and error method. Okay, so these three are the methods in operation research. Okay. Now, if you look at page number 108, he has given you a few techniques which are used in OR. Okay, you have probability theory, statistical methods, frequency distribution, linear programming, transportation problem, game theory, decision tree, PERT, CPM. So all of this, these are all your OR techniques. Okay, and we will be looking at, many of these are already covered. So you break-even analysis, you already know, right? NPV, you know. Discounted cash flows, you already know. Variance analysis is standard costing. You might have already studied that. Okay. We have PERT and CRM also. Mostly this we will be looking at LPP also. Okay. So that is linear programming. Linear programming is also there. Yeah. And the thing about operation research is, this is very specific to specific scenario. So it is, if you have a problem and you cannot randomly apply any technique. Okay. So suppose there is a problem and it is a specialist kind of a field. Okay. So you will have to know which technique to use and when. Okay. So it is like you cannot use decision tree approach for simple investment decisions. Okay, so for that you have to do your NPV. So that kind of knowledge you have to have prior. Okay, so that is why operation research, it is a specialist job. It requires a special set of skills. Okay. So you will have people like statisticians, statistics experts, or probability people who deal with those, and math experts, and even we have finance experts also, CA, CMA people. So we can become OR specialists. Yeah. And he has, so as I was saying, he has also given which all techniques are used in which kind of a functional area, if you see. So if you see in production management, you have selection of plant and product mix. You have BE mathematical, that is break even mathematical. You have discounted cash flows and NPV, and you have linear programming, simplex and graphical methods. Okay. So specific decisions require specific kind of a techniques. Okay. And in material management, we have already seen EOQ, and you might have already studied group 1. If you have studied, you would have done ABC analysis and VD matrices. Okay. So yeah, so these are the specific techniques which are used in a few functional areas. Okay. Yeah. Okay. So now let us see the functions of operation research. Yeah. Okay. So Neha, you are following?
Yes, sir.
Yeah. Okay. So if you look at the functions of operation research, it gives you a scientific basis for decision making. Okay. So as we have seen from the definition of operation research only, it's a scientific method or an analytical method to help management get to decisions. Right. Yeah. And it reduces complex problems to simple problems. Okay, so see, sometimes what happens when you are trying to look at the big picture, or when you are trying to solve a complex problem, you cannot generally come into that complex problem solution at once. So what you have to do, you have to break that big problem into little problems. Okay, and then try solving each of the problem, and then ultimately you will get the solution to the whole problem. Okay, so using OR, you can divide the complex problem into a simple problem. Okay. And it brings trade-offs. Okay, what is a trade-off? Trade-offs. Trade-off is nothing but it's a compromise. It's a compromise. Okay, so we have seen EOQ, right? In EOQ, what is the scenario? The scenario is you have to handle, you have to place the number of orders and the inventory cost. You have to balance both. Is it right? So in EOQ, the total cost is equal to your ordering cost plus inventory cost plus storage cost. Okay, so this, we have nothing to do with this, but we determined what is the order quantity and how much is the storage cost. Now if you talk to a production manager at a company, now what he will say is, I do not want anything hampering my production. You people keep ample inventory. That is what he says. So if he requires say 10 units a day, he doesn't want to take the risk. He says you maintain 1000 inventory. Right. Okay. And this ordering person, now suppose a person who has to procure raw material. Now if you go and tell him, so raw material in how many orders you want to procure, he might say, no, I'll just procure once every year. Okay, his job is simplified, right? If he does that, I'll procure once every year. Okay, I'll procure your whole annual requirement. Okay, but will that work? If you do that, your inventory cost shoots up. Right. So there's always a compromise. So what you do? You have to increase your number of orders and you have to decrease your inventory in such a way that it will not hamper your production process and it will not increase your total cost. Correct. So this is a trade-off. It is a compromise between saying that I want 1,000 stock, you keep it in the inventory and you hold it, it is a trade-off, right? So it brings that kind of a trade-off. And it also provides you system integration. Okay, so if there are multiple systems working in your organization, using OR, you can integrate all of those systems into a single system. Okay, it also helps you in optimizing your resources, minimizing your time, minimizing your cost, maximizing your profit. And also, it also helps in the selection of best alternatives. So as we know, if you have some investment decision, you have two projects, A and B. And how do you arrive? If you are given different cash flows, so you do your analysis, right? You can use NPV, you can use IRR, you can use XIRR. So all of these are operation research methods. These are scientific methods. Okay, yeah. And they provide solutions to specific problems. Okay. So these are all the functions of your operation research. Yeah. You can go through the limitations. So as I was saying, in the limitations are basically it requires very special skills. It requires special skills. Okay, so you need experts. Okay, and also if you have too many variables, it will be very challenging. If you have too many variables, it will be very challenging. Okay, and also sometimes what happens, as we have discussed the steps in operation research, what we have discussed to come up with one problem statement, right, the first step. But sometimes it is very difficult to arrive at one problem statement, because in practical scenarios it is difficult to to get a single objective function. Okay. Yeah. So that is the introduction on operation research. Okay. Yeah. It is theory and it is problematic also. Yeah. So the last, if you see last 40%, that is strategic management, that is completely theory. Okay. And also in the first 60%, you will have 80% problems and 20% theory. Yeah. But strategic management, it is completely theory. Okay. Production planning and control. Okay. So what is production planning and control is, as the name says, it is the planning and control of production. Simple. It is the planning and control of production with an objective. Now what is the objective? So the main objective of PP&C is to deliver the products to customers or to inventory stocks according to some predetermined schedule. Okay. So if the main objective is to fulfill customer order on time, okay, it's a predetermined schedule. Okay, now suppose or inventory stocks, so it is the same. Inventory stocks is nothing but you keep the stocks manufactured and keep it in the inventory, and fulfill customer orders also, you don't keep it in the inventory, you sell it to the customer. So it is mainly the manufacture of stocks. So suppose you have an annual plan of, say 10,000 units of cars. Okay, you are a car manufacturer. Okay, so you have an annual plan of 10,000 units of car manufacturing. So this is your objective, right? So everything else will work backward. Okay, so if you have to make 10,000 stock, so how much raw material should you procure, how much and when, right? How many labor hours are required, how many machine hours are required, right? So all of these planning and control is about production planning and control. Okay, so planning is, you have to just determine how much and how much quantity you need for the year and in the batches, that way. But control is, you have to see that you are not deviating from your plan. Okay, control is nothing but you have to see that you are not, no deviation from plan. If you have any deviation, then what is the corrective action that is required? Okay, so suppose you are falling behind on your first quarter. Okay, so you have to manufacture say 2000 in your Q1, but you have only managed 1800. So now the corrective action will be the 200 which you have missed in Q1, you have to somehow make up in your rest of the quarters, right? So this is the control mechanism. So that's it. So that is the main definition of production planning and control. The main objective is the predetermined schedule should be followed, or whatever you have planned, you have to execute it. Okay. And what are the functions that PP&C controls? The functions is planning, routing, scheduling, dispatching, follow up, inspection. Yeah. So these are the functions. Okay. So it is planning the production, and then routing. Routing is nothing but it's a part of your production. So you have to, if your production process moves through some kind of a chain, so you have to route it, right? So that is routing. And scheduling is the scheduling of jobs, right? So scheduling your labor and what job has to happen at what predetermined schedule. So that is your scheduling. And dispatching is dispatching your, maybe your raw material, or your goods to the warehouses, to the factories. Okay, and follow up is the control which we are talking. So we have to take necessary action if something is not going according to plan. And inspection is your occasional checking, so for quality to be maintained, right? Yeah. So you have, in control, you have types of control. Okay, so you have block control. This is nothing but how your process flows. Okay, so if your process is say a product wise process, so you'll have product wise control. If it is a batch job, it's a batch wise control. Okay, so that is your block control. You have your flow control, load control, okay, order control, and you have special projects. So the special projects is huge investments, right? Special projects are like your highway construction. Okay, then you have some, if you have a big real estate project or something, so those are all special projects. And if it's a batch job floor, you have a batch control. Okay. So these are the various types of controls. Okay. Okay. So the next chapter 4.3, you can just give it a reading. Okay. It talks about various types of studies. Okay, what is a time study, a motion study, method study, and work study? Okay, you can just give it a reading. It is a very simple topic. Okay, so generally, what a work study, it deals with the human effort. Hmm? Yeah. Okay, this is the human work and the method. So time includes method and equipment. Okay, this is time study, and method is just the process. Okay, and motion study, it deals with the movement. It deals with the movement of your process. Okay, so basically all the aim is to bring more efficiency. It is to increase efficiency, and if there is any unnecessary processes or inefficient processes which are being followed, so you want to avoid those, so you want to cut down those. Okay, and bring in the efficiency. So this is basically what it is, just studying your process. Okay, based on the parameters like time, method, motion. Okay, and work study. Okay, you can just give it a cursory reading. Okay, it is not very difficult. Yeah. Okay, so now we will look at linear programming. LPP is nothing but linear programming problem. Okay, yeah. Okay, so let us look at the decision. So LPP is also an OR technique, right? This is an OR technique, and we will learn how to solve a problem using LPP. Yeah. Okay, so linear programming is an optimization technique. So if you look at the definition, it says it is a technique for specifying how to use limited resources or capacities of a business to obtain a particular objective, such as least cost, high margin, or least time, when those resources have alternate uses. Right. So he says you have resources, and these can be used in n number of ways. 1, 2, 3, up to n. Okay. You are to arrive at a particular use of this resource so that your objective, so suppose that is your objective, is for least cost. Okay. So you have to find out how to use your resources to arrive at the least cost. Okay. So this is your linear programming. Yeah. So linear programming has two parts. The first part is objective function. So as we were looking at the steps in operation research, the first part is to get the problem statement, right? So that is also called as the objective function. Objective function or problem statement. Okay. So that will be your step 1. And the second part is the constraint sets. So we were already we discussed, so that is your variables. Okay. So using your variables, you have to define your objective function. Yeah. So he has given you various areas of application of linear programming. Okay, you have industry application where you can take decisions of product mix, product scheduling, transportation problems, product distribution. So you can solve all these problems using linear programming techniques also, right? And you have management applications as well. Portfolio selection, financial mix selection, profit planning, traveling salesman problems, and all of this. Okay, and you have other applications as well. Now let's look at the steps to solve linear programming problem. Okay, first step is find the key decision to be made from the study of the solution. Okay, so find the key decision. So that is a problem statement. So it may be, say Z should have minimize cost, right? Minimize cost. This may be your key decision, right? Second is identify the variables and assume symbols. Identify variables and assume symbols. Okay, so say suppose raw material, it is R. Okay, labor, it is L, right? And you have distribution overheads, say D. Okay, so these are your variables for this decision. And you have to do using these symbols. Yeah. Express the possible alternatives mathematically in terms of variable. The set of feasible alternatives generally is given in the situation. Okay. So possible alternatives, as we have seen in this previous slide. So these are all the possible alternatives, right? So this you have to express. We will get more clarity when we solve the problems. So just try to understand the steps. Step 4 is mention the objectives quantitatively and express it in linear function of variables. Okay, so you will have to get a linear function. Linear is nothing but a straight line, right? So it may be z equal to, say, variable v1r plus v2l plus v3d plus so on. Okay, so this is nothing but this is a linear function, right? So you are expressing your problem statement in terms of your variables. Okay, so it's like just AR, this is some number, this is a constant. Okay, so a constant into your variables. Yeah, and finally it is express the constraint in linear equalities in terms of equalities or inequalities in terms of variables. So that is how you solve a linear programming problem. Now let us see the types of solutions. Solutions in an LPP. Okay. First solution is, it is a solution that it will satisfy your constraints. Okay, so suppose z equal to, you get 3r plus 5l, suppose. Okay, so if this solution is holding good in all values of r and l, so this is a solution, right? So you have solved the equation and you are getting the total cost as this function, right? So this is a solution that satisfies all your conditions, okay? Second is a feasible solution. Okay. Now what is a feasible solution? Now suppose somebody says, if you work every hour, so for 1 hour, I will pay you 1,000 rupees. Okay. Now the problem statement is, how many hours you have to work in a day for you to earn 35,000 rupees. Okay. So Z equal to N into 1,000. And you know Z equal to 35,000. So N is equal to 35. Now this is a solution. This is a mathematically correct solution. But can you work for 35 hours in a day? Because in a day you have only 24 hours. Right. So even though this is a solution, this is not feasible. So anything that is not feasible is not a feasible solution. So if suppose I say you 16,000 you have to earn, then you get N equal to 16. Right. Is this feasible? Yes. This is a feasible solution. So anything which is doable, that is a feasible solution. Anything which is not doable, that is not a feasible solution. Okay. And basic solution. Okay, what is basic solution? Now suppose you have two unknowns and you have two equations. Right. So I'll give you y1 equal to, let me give you something like 10 equal to 5a plus 2b. Okay. And another equation I'll give you 15 equal to 6a plus b. How many unknowns you have? You have two unknowns, that is a and b. How many equations you have? Two equations. Right, these two equations. So if you have two unknowns and two equations, you can find out a and b, correct? So suppose the unknowns is n and equations is m. So if n equal to m, you will get a solution. Yeah. Now suppose if n is greater than m, plus 3c plus minus 4c. Now can you solve? Now can you find the value of a, b and c using two equations? You cannot. You will need three equations. Okay. So you cannot solve this equation if you have only two equations. You can try n number of ways, you will not get the solution. Okay. So in this case, what we do for a basic solution is, we assume c equal to 0 or b equal to 0 or a equal to 0. Any one variable, you give it a 0 and then you try solving for the other two. Okay. So this is called basic solution. Understood? If you have more unknowns than the number of equations, so for how many ever more unknowns are there, you assign them 0. So if you have plus d plus e plus f and plus d plus e plus f plus g, something like that, you will assign 0 to all of these. You will only have to have two unknowns. Okay. So that is called basic solutions. If n is greater than m, you have to bring it in such a way that you should have only m unknowns. Okay. So n minus m variables should be assigned as 0. That is basic solution. And what is a basic feasible solution? So if you do this, you will get some value of a and b, right? Just assume you have two equations, a and b. Okay. So if A and B are, the values of A and B are not in our feasible limit, so that is not feasible. If they are in the feasible limit, that is feasible. So as we have seen the previous problem, we got 35, right, hours in a day. So that is not feasible. So if there is some kind of feasibility condition, and if A and B values do not fall within that, then it is a not feasible solution. Otherwise, it is a feasible solution. Okay. And you have optimum feasible solution. So what is that? So suppose you have you get 3 solutions to a problem. Okay. So which is more optimum? So that is optimum feasible solution. Okay. Yeah. And degenerate solution. Degenerate solution is nothing but if you are getting the value of A or B equal to 0 while solving, if you are getting A or B equal to 0, so if one or more variables become 0, that is called a degenerate solution. Okay. Yeah. So these are the different types of solutions. Okay. Okay. So let us look at a small problem and then we'll wind up. Okay. So that if you look at the problem, you will better understand what we are talking about. Okay. Yeah. Okay. So you can look at illustration 1, page number 135. Yeah. So he says a chemical company produces 2 compounds, A and B. The following table gives the units of ingredients C and D per kg of compounds, A and B, as well as minimum requirements of C and D and cost per kg of A and B. Okay, write down the problem mathematically for minimization of cost. Okay. So you have C, D, 2 compounds are there, A and B. So for each unit of A, you need 1 C and 2 B. Three and 1. Okay. Okay. Now objective is to minimization of cost. Right. So say minimization of cost. So what is your total cost? Four units of, so number of units of A and number of units of B if you are manufacturing. 4A plus 6B is your total cost. Correct. So you have to minimize that. So this is the, so what is the minimization of cost? Right. This is your step 1. Objective function. So whatever he is asking, that is your objective function. Right. Okay. And now he has given you a constraint. He has given you variables. He says the minimum quantity of C is 80 and D is 75. Right. So he means how many units? So A plus 2B should be greater than or equal to 80. Right. You have to manufacture 80. So ingredient C 80 should be used. Right. Constraint required for ingredient C. And then 3A plus B be greater than 75. Minimum requirement, he says minimum you have to use this many. Right. So you have to use 80 units of C. This is for C and this is for D. Right. So if you number of units of A plus 2 into number of units of B should be greater than or equal to 80 because you use 2 units here, right? Similarly, 3 into number of units of A plus B should be greater than or equal to 75. Okay, so these are your constraints, and this is your objective function. And you will always have A and B should be greater than 0, right? What if one of them happens to be 0? That's a degenerate solution. Correct, correct. So these are the 3 equations, and this is your maximization function. Okay, any doubts? Yeah, so we will stop here. We will look at LPP in detail in the next class. Okay, and also then we'll move on to other problems as well. Okay, Neha, understood?
Yes, sir. Thank you.
Okay, thank you.